Hi guys, in the last part of this video we were talking about dissolving a solid. We looked at the first part of this is breaking down the substance. Now we're going to look at the second stage, which is incorporating the free ions into the solution. We call this stage hydration if we're dissolving within water. It's important not to forget the big picture here. We're talking about solution, which is dissolving a solid. That's the big blue box. And then we've got two steps within that. Firstly, breaking down the lattice, and now we're talking about the hydration. It's important to keep in mind that hydration is just one step within the greater process of solution. To be able to have hydration take place, we need to have similar interactions between the solvent, which is what does the dissolving, i.e. the water, and the solute, which is the thing being dissolved. We need similar interactions between these two as we had originally within the lattice. This means that ionic solids, which are held together by electrostatic interactions, dissolve well in polar solvents like water. Let's look at why this is. We've got our water molecules, which we can label H2O, and then the oxygen is so much more electronegative that it pulls the electrons towards it, and we get a slightly negative pole at this end. This curly D symbol just means slightly, for slightly negative, and then we get slightly positive poles at the hydrogen ends. We then can have interactions between the water molecules and the negative chloride ions. So you form these interactive bonds here, where you've got all of the slightly positive hydrogen ends ending up close to the chloride ion because they're attracted to the negative side, and then you've got all of the slightly negative points on the oxygen end facing the other way. We get the same process with the positive ions in our solution, but this time it's the slightly negative oxygen end which is attracted to the positive ions. So when we look at the shape that's formed when all of these interactions happen, we've got all of the slightly negative ends facing inwards, and then all of the slightly positive ends of the water molecules facing outwards. When these bonds have all been formed, the water molecules surround the positive and negative ions. This separates them and stops the solid reforming. When these bonds form, energy is given out, like usual when bonds form. So we have a new enthalpy change to think about. The definition is that the standard enthalpy change of hydration, delta hyd, and then H standard, is the enthalpy change when 1 mole of aqueous ions is formed from gaseous ions.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today and together let's make A-level chemistry a walk in the park.